Welcome to Math Intervention Resources and Strategies for Middle and High School. This presentation you can access through this QR code, so you may want to go ahead and scan that. There are a lot of embedded links throughout my slides of great places to find evidence-based resources, so that QR code could be really helpful down the road. And then also, I believe the presentation is shared through the conference, so obviously you can get the slides through that as well. But we have basically three goals for this presentation. One, I want to talk to you about how I uncover student needs when I'm doing intervention. I want to talk to you about evidence-based resources and intervention strategies that are super quick and simple, because the focus of this presentation is middle school and high school. And a lot of times intervention at that level, particularly when you're really looking at just a tier 2 student, a student who might just be lagging or struggling in one specific area, those students can't always be pulled out because their schedules are all very different and they're diverse. And so it's really easier to provide the intervention in your actual classroom in the 40 or 50 minutes that you have them. The problem with that, obviously, is that you only have them for 40 and 50 minutes. So how do you provide that intense intervention on skills for students who need it, but also make sure that you're honoring, your whole class and moving through your curriculum? And so this presentation will give you a few ideas about how you can practically do that in your course next fall. So a little bit about me. I always think it's nice to know who's presenting to you. And when I'm presenting, I really like to know who's in my room. So I really miss that with these online presentations. But I've been in education 19 years. 10 years I taught in plain local and I taught math. I taught 6th, 7th, 8th grade and Algebra 1. And then I moved to Malone University and I did a lot of work with pre-service teachers and field experience and some administrative work. And then for the last 4 years, I've been at the University of Mount Union, and I teach a variety of courses, but I teach preschool through 12th grade math methods. So really any level of teacher who's teaching math. I teach the methods of instruction for that. And then I also teach some planning courses and then some special education courses as well. And then a couple things about me that I think are interesting and might be helpful to framing this presentation is while I was a math teacher, I also have a master's in special education. And I really focus some of my research on how adults progress through education and how their numeracy skills or their number sense skills influence their future life choices. Because I think there's a connection between problem solving, reasoning, decision making, and mathematics. And so I do look at how adults learn and how math numeracy impacts them. And in my free time, I love to hike, boat, and camp. And because this is pre-recorded, I could be doing one of those things right now. But as you can see, a third of my family from this picture does not share my love of the outdoors. I'm sure you can judge from those teenage faces which ones may be happy and which ones not so much. But the goals of mathematics are something I want to go ahead and start with. We really have three goals when we're teaching mathematics, and it's not that students can get the right answer. The first is we want students to have conceptual understanding of our math topics. We want them to understand the how, we want them to understand the why, we really want them to understand how topics fit into the greater picture of math. We also want them to have procedural fluency, and I'll talk a little bit more about what that means, but it's not necessarily that they can do math really fast, which is sometimes a misconception. And then I know my head is over the word problem solving, but we want them to have problem solving and transfer abilities. And so when you're looking at this from more of a special education lens, procedural fluency would be maintenance of skills. We want them to be able to use their skills regularly and efficiently and correctly and accurately. And then problem solving and transfer would be more the generalizability of skills that they can use them in more non-routine situations. When I'm talking to people who don't deal with math every day, which probably isn't you if you're watching this presentation, but this might be helpful to you too, so I'll share it really quickly. And I'm trying to talk about these three mathematical goals. I often talk about tying shoes. So conceptual understanding is really important when you're teaching kids to tie shoes, because tying shoes is frustrating. If you've ever worked with a little kid on tying shoes, it is a hard skill. There's a lot involved with fine motor and thinking. And so conceptual understanding really needs to probably come first. We need to tell kids, like, you're going to do this really hard thing, and here's why it's important. Here's why you want to do this. We don't have Velcro shoes forever. Vans are cool, but you can't wear Vans all the time. And so we have to learn to tie our shoes because we want them to stay on our feet when we go to recess. And if we just tie one loose knot, that's not good enough. It won't stay on our feet. And so we need to learn how to tie so that they stay on our feet all day long. So that's giving them the conceptual understanding of why this is important, how it fits into their world, and how it fits with the other things they already know. And then we can move on to procedural fluency. And that's the steps, the procedure of tying shoes. And if you remember when you were a little kid, that was a really super hard procedure. Lots to think about. You messed it up. It was frustrating. As adults, we don't think about it at all. Like, you just tie your shoes. And that's procedural fluency. It's not about how fast you tie your shoes. It's about what is the cognitive load needed for you to do the task. And the cognitive load when you do something with procedural fluency is very low. If you are thinking about every single step, you might know the procedure, but your procedural fluency is pretty poor. And so you're really not able to do that task fluently. And so that's kind of the difference. Some people think it's just how fast you can do it. And a lot of times if you have procedural fluency, you're pretty fast. But it's more about the cognitive process that's happening that makes you fluent. And then problem solving and transfer is that we hope our students all turn into MacGyvers. They know how to tie shoelaces so well that they could do all kinds of fancy things like drive cars or like disable bombs or whatever, but use their skills in a non-routine way, in a way that we never imagined. And that's always our dream as a teacher, is that they're taking what we give them and they're using it to better their lives outside of our classrooms. And so they become MacGyvers. When I'm looking at math specifically and I'm uncovering skills for students, I really look at three sources of information. There are three types of assessment, really essentially, that we probably do as math teachers. The first are general outcome or curriculum-based measures. And those are assessments that go over a gamut of skills and you give them regularly throughout the year. And you're looking for kind of student growth, you're identifying gaps, from that data. A great resource is this National Center for Intensive Intervention. And this resource, I'm going to go ahead and visit that for you. It's linked in here if you want to find it later. Is a really excellent resource, particularly if you are a lead teacher or a curriculum person. This might be a really excellent place for you to go, but it basically helps you identify what are researched, evidence-based interventions and assessments in different areas. So I'm going to go ahead and look at evidence-based interventions. You could look at assessments. They're kind of the same. And it'll talk about different resources. It looks at academics and behavior, which is really nice. And it will look at validated programs, and you can sort by middle, high school. You can sort by mathematics. Let's go ahead and do that just so you can see. And it'll tell you about different strategies or different research that goes with it. It will talk about the intensity of that program. How often should it be done? Do you need training? Who can do it? But it's a really good resource to get ideas that you know are evidence-based and that you can back up as great choices. So this is one I often go to when I'm looking for ideas on how to intervene with students, and looking at assessments that I know are evidence-based and have really been rigorously reviewed. Mastery measures are typically those quizzes and tests that go with the curriculum that you're teaching. So, chapter 6 test, your chapter 1 quiz. Those are kind of mastery measures. It's mastery of the content you've just taught. And then obviously we use a ton of formative assessments in mathematics teaching, a ton of observations about what students are writing down. We regularly question and interview. You may not call it an interview, but when you're talking to students about their thinking and what they're doing, that's essentially interview them. And then also exit tickets. And I did put this little video in here. If you're a P5 teacher and you've found your way to this session, Marilyn Burns has a really awesome new interview protocol where there's a series of questions and students give their answers, and you listen for certain ideas or misconceptions or understandings through those protocols. It sounds really amazing. So I did drop that in there. If that's something you're interested in, feel free to check that out.
What is 9?
So we're uncovering. I have a skill my students are learning, and what I'm looking for when I'm uncovering is not, are they correct? And is the work on their paper correct? I'm not looking for that. What I'm looking for when I'm trying to uncover is, do they have conceptual understanding? Do they understand the how and the why and how this fits into the larger spirit of this math that we're doing? And do they have procedural fluency? Can they follow the procedure or strategy? And can they do that in a way that it's not causing them to think so deeply about it that it's really dragging them down? Because if they're thinking too hard about the procedure, they're going to have trouble problem solving because their capacity, their cognitive load is full just from walking through the steps. And so they can't think creatively about problems if that's what's going on. So I look for these two aspects when I am kind of assessing or uncovering students' misconceptions and providing intervention. So that's my framework that I use. And so I'm going to tell you about two students throughout this presentation. Both of them are going to be kind of different aspects of struggles. And so you can kind of see what I look for, how I think, and maybe use that as a model for yourself. So I had this student, I'm going to go ahead and put all this on here. She was an online learner. So she had moved from face-to-face to online this academic year. She was a pretty high performer, got good grades. She was in an algebra class, and but she was a middle school student. And she was an interesting case because I kind of got called in. So she was doing really well. She was not having any problems. And she was on a multi-step equation unit and had gotten to the questions that were literal equations. And so literal equations are typically formulas where you're solving for a variable, but you don't have many numbers to deal with. So just a lot of variables, and you're solving for one of them. And so she was very successful with multi-step equations, had gotten really good grades, and all of a sudden just like literally could not move on because she didn't know what to do. So I came to her, and usually when I have students struggling with equations, my first thought is usually conceptual, my first thought is that they memorized a set of steps to solve equations, but they have no idea what they're doing. That's typically what you see with students who struggle with solving equations. Unfortunately, that was not the student's problem at all. So I gave her the problem 2/3 x minus 2 equals 4. And I was like, all right, if she can solve this with steps, she probably has procedural fluency, but she probably can't solve this. And I gave it to her, and she told me the answer right away. And I was like, wow. And I said, how do you do that? And she's like, well, I don't really know. I just figure out what number goes in for X. And I was like, so how do you do that? And she really struggled. She couldn't really tell me what she did, but I gave her several problems and she could solve them. And that's why she had been so successful, is many of her online quizzes and tests were multiple choice, and she was able to reason through them because she understood conceptually what equations were and conceptually how they worked, but she really was unable to communicate what she was doing. So she was missing some procedural fluency, and I also believe she was missing kind of some academic language. She really didn't understand how to notate her thinking, because that's really what solving equations is when we write our steps, is notating our thinking and our discourse. So when I gave her, these equations, she couldn't write down the answers. She couldn't write down the steps. She really couldn't even discuss what she did. She just sort of knew the answers. So I thought, all right, she has great conceptual understanding. I'm not worried about that at all, but she really has procedural fluency, and we need to work on that. Student number 2 is sort of the opposite story. We were working on functions with this student. She was a face-to-face student, pretty average student, really hard worker, and she was an 8th grader. And we were working on, is this a function? Is this not a function? And she's such a hard worker that she had memorized the definition of function, that each input gets exactly one output. And she knew that definition. So she had procedural fluency in a sense, and she actually could look at these problems and she could get them all correct. She got all 8 of these problems correct that we did. But it took her a really long time, like a very long time on each question because she would literally look at each one and you could almost visibly see in her head her thinking, does every input have an output, like over and over again, to find out which one's a function and which one wasn't. And so while she kind of knew the procedure and she kind of had procedural fluency, but it wasn't very fluent because she was using a lot of cognitive energy. The reason she was using so much cognitive energy is she had no conceptual understanding of what she was looking for. Like, she had no idea what a function really was. She just memorized a definition and was using that definition to answer questions, but literally didn't understand how functions fit into the world of math. Like, no idea. So I knew for her, I was going to do a conceptual intervention for her because I really felt like procedurally she knew how to solve these problems and she was getting them right. But I could make her life a lot easier and remove some of her cognitive load if I could show her kind of the backdrop of like what she's doing and why this is important. So when I'm looking for interventions to help with procedural and conceptual, one of the places that I go to other than the intensive intervention site that I showed you earlier is the What Works Clearinghouse. There are links on this page to take you there, but the What Works Clearinghouse is a site from the U.S. Department of Education that kind of does a similar thing. They really do reports on evidence-based practices that should be used for intervention. And they're awesome reports that are not scary reports, but they're really practical. Like, here's a strategy, here's exactly how you implement it, and then here's barriers that you're probably going to come to, and here's how you solve those barriers. So I put some images, but I'm just going to click one and give you a quick glimpse of what one looks like. So these right here are interventions for elementary mathematics students. And you can see it provides you with 6 ideas and that they have strong evidence. And then if you click on this, it'll go ahead, you can click on it and it'll show you more about that particular idea. So this is recommendation 3, that we should use representations. And it walks you through what a representation would look like. It talks to you about how to carry out this recommendation. And then if you scroll down a little bit further, they always tell you obstacles and advice that can be used to kind of overcome obstacles. Or if you know you're a coach and you're working with teachers and they cite these obstacles, like my students are confused by the different representations, here's their advice on that. So it might also help, from a math coach perspective. These are probably things people are going to say to you. And so how do you overcome them, or what advice do you give them? So I love What Works Clearinghouse. I think it provides a lot of really wonderful resources and would be great for kind of personal and professional development on how you implement different research-based strategies. So here is a couple that I use a lot. These are obviously not exhaustive, since we're only talking about 5, but I only have a half hour, so I thought I'd just pick 5. But a lot of times when I find a student has a conceptual misunderstanding, I fall back on the idea of CRA, sometimes it's CPA, the concrete representational abstract idea. And essentially that understands that the continuum of how we learn things is we need to touch and feel concretely, then we need to see it represented in pictures or drawings or diagrams, and then we can move on to the abstract, and we can really look at things like math equations and expressions and look at it more abstractly. So a lot of times when a student has a conceptual understanding, they're too far. They might be at the abstract, but they never got the concrete representation. And so you kind of have to back them up and reteach that series of understanding and sort of re-uncover the skill for them. When students have procedural fluency problems, I really like these 4 strategies only because they're super easy to implement in sort of a regular classroom setting. So when I don't have the opportunity to pull students out and I need something like right now or something that's a low prep, these are typically the 4 that I go to, and I create space in my classroom to use these 4. There are tons of other interventions, obviously, but all of these are evidence-based and are really pretty easy to implement with little prep. So the first is solved problems. Solved problems are awesome because they're pretty easy to implement. And let me find it for you. Sorry about that. So solved problems. This is again from the What Works Clearinghouse, and I like this because they show you different types of solved problems. So, you can look at problems that are solved just correctly and kind of study those. You can look at problems that are solved incorrectly and correctly. So here's like two different responses, and you can see kind of who's right or different strategies that way. And then you can also look at solved problems that have blanks that students need to fill in. And so they're kind of responsible for some of the information, and they can interact that way. So solved problems, providing the model and having students analyzing the model, helps them learn about how we talk as mathematicians, how we communicate as mathematicians. They can also do kind of an error analysis for that higher level thinking, and then also interact with partially solved problems, which is really helpful. Another one that I use a lot is cover, copy, compare. So cover, copy, and compare, you basically take a piece of paper and you can fold it into thirds, really any way. It doesn't really matter how you fold it into thirds. And then basically you solve a problem with students. So you have them actually put a problem and then solve it. And then you cover that up, or I just have my students unfold their third and hide it. And they have to copy a problem and solve it by themselves without looking at my model. And then they compare the two to see how they did. And if they got them correct, great, you're gaining fluency, we can move on. If they didn't get correct, they have to solve that problem again until they get it correct. And then you do that multiple times systematically over time until a student is completely comfortable with that. Taped problems is another strategy that's pretty easy. It's one that takes a little pre-planning, but in the digital world we live in, I feel like this one's pretty easy to do. You essentially tape yourself solving a problem, and then a student watches you do it, and they kind of try to beat you so that they're showing that they have fluency faster than you. And then at the same time, they're getting a really good model. So I think that's something that can really be easily done in a classroom these days with kind of how we're used to teaching and how students are now used to learning in a little more independent virtual way. And then incremental rehearsal is a really good strategy as well. I can see this being really beneficial at kind of that lower end of middle school. I mean, it's so beneficial in lots of ways, but one example would be like when you're teaching the 4th, 5th grade range and you have a student who comes to you from 3rd grade and they have not fluently memorized their multiplication tables. Some of them maybe they have, but some of them they haven't. Incremental rehearsal says that what you're going to do is you're going to give students some unknown facts mixed with known facts. So as they're practicing, let's say they have 6 flashcards to learn, maybe 2 of those are unknown and 4 of them are known. So when they're practicing, they are getting some correct because they know them, and there's only a few that they do not know. It reminds me of something in special education we call high probability sequence. It's essentially this idea where you don't want to present students with this overwhelming task that they cannot do. So we break that task down into smaller strategies. And so then we put the easiest thing first. We ask them to do something we absolutely know they can do. And so you work them into the more difficult task by stringing together things you know they can do and leading up to something that's much more difficult. So it provides sort of that motivation. It provides that ability to know that you are successful. And when you're doing incremental rehearsal over time, you're consistently putting new material in until they've kind of mastered the set of material. So how do you do this in a classroom? That's always the challenge, right? So one book that was given to me by a teacher friend that I think is amazing is Maximum Tier 1 Support by Pat Quinn. And essentially he proposes that there are 5 different ways, and there's probably more than this, but 5 that I thought were pretty good ways that you can use your classroom time creatively to provide you with that time for intervention. And I think this is really great. I think I would not do it every day, but I think, integrating this into your regular weekly routine would be a really great idea. So the first one is assess and adjust. Assess and adjust just simply means that you're going to start and you're going to be teaching a class, and then you do an assessment next. So almost like an exit ticket in the middle. And then based on how students do on that, you can put them into different groups. So do they need a prereq remediation? If so, you could do something like a taped problem. Do they need a reteach? Maybe that's where you're meeting with a group and you're providing an intervention strategy. Do they just need to try a few more because you're not really sure? And then maybe they need a challenge. So you can kind of put them off into groups based on this assessment in the middle of class. Begin and branch is where you teach as fast as your fastest learner is going to get it. And then you give an assessment. I can see this being really good with cover and copy. And so they might do a cover copy problem. If they're all getting it right, they're comparing, and these students did that, and this student got it right. He's going to branch off and he's going to come over here and do independent practice. But these three are going to get another example. Maybe it's a cover and copy again. And then you're going to go ahead and branch off a student, and these are still going to be with you and do another example. And then maybe these all get it, and now they're all doing independent practice. So you're basically teaching the fastest you can and branching students off who do not be sitting with you doing the extra practice. A work down bin is a great idea. And essentially you come up with like a list of activities students work through. You always want to put those in the list from most important to least important because they may never get to the end, and that's fine. They work at their own pace. This allows you to see what students are sitting there on activity 1, longer than other students, and intervene with them. I can see this being great. My student who was working on functions, she would have been stuck on activity 1 for a while, even though she was doing great with it. So it would have allowed me as a teacher to come meet with her and intervene and kind of figure out what was happening with that. The next one is creative choice. And that's really not surprising. It's just that your assessment strategy is really based on universal design for learning, and you allow students some flexibility in how they choose to do their work. Is it an oral presentation that they're giving you their answers? Are they working through them with a partner? Are they writing on a piece of paper by themselves? And then a keyed activity assessment is an assessment where every question tells you something about what that student can and cannot do. And then based on how they did on that specific question, it keys them to complete an activity or not to complete an activity. So maybe question number 1, the student got that correct. So they really don't need activity number 1. But question number 2 and 3, they did not get correct. So that tells you that they might need to go do activity 2 and 3 and practice those skills. But in all of these situations, you're breaking your class into smaller groups or individual groups where you as a teacher can then claim that time to go ahead and do some of these intervention strategies with the students that need them, which I think is what's the most important and probably just the most reasonable way to provide intervention in a setting where you might only get 40 or 50 minutes with each student each day. Okay, the next thing that I want to talk to you about is our students again. So what did I do for them? So our first student, remember, was struggling with literal equations. She really didn't have the ability to show any steps or any procedure or any work. She just didn't know how to do it. It was something she never learned. So for her, I used 2 strategies. I used solved problems. So I first gave her 3x plus 5 equals negative 16 alone, and I had her tell me the answer and kind of talk to me about what was going on in her head, which again, she struggled to do. And so then I gave her this problem worked out by a student, and I said, I want you to tell me what this student did. Let's talk about this example together. And so she said, oh, this is what they did, and talked to me about their process. And I said, yes. I'm like, this is how we talk about math. This is how we communicate math and communicate our thinking and our steps. Would you want to learn to do that? Because I think it's really going to help you with our literal equations that we're working on. And she was like, yes, of course. So I did a cover, copy, compare. So I had a box here that had the problem that we were working out. And then this box is the one that she had to copy herself without looking at mine. And then she had to compare. And if she got it right, that was it. And if she got it wrong, she had to use this third box. So we kind of folded the paper along this dark line so she couldn't see the examples as she did the copy without looking at my example. And we actually began with just multi-step equations, And then about halfway through, we transitioned to literal equations. And she almost could seamlessly do literal equations because she understood equations so well before we started. And once I gave her the language or the step or the procedure, and we did that over time, she really was very successful. And really transitioned very seamlessly to having both conceptual and procedural understanding. But it really took the combination of that solved problem and the cover, copy, compare over time to make sure she had a solid foundation of that. And so she's good to go. The next student, remember, we were talking about functions, and she thought so long and so hard about that definition, and she got all of them right, which was awesome, but she really needed some conceptual understanding to take some of that procedural thinking, that cognitive load that she was experiencing off of her. And I think, in elementary school, we use a lot of concrete hands-on manipulatives. We use a lot of blocks and things like that. But in middle school and high school, some of the topics that we're learning are so dynamic and multifaceted that we need a representation that is a little bit different. So a lot of times I fall back on GeoGebra and Desmos to show those relationships. So I'm going to go ahead and visit Desmos. This is the one I used for this student because she needed to see what a function was because she really was not understanding. And I loved this Desmos activity because it allowed you to sketch a graph, and then the person in the Canon would do whatever your graph was. So an example would be, you could do something like this, right? And then we can play that. And you're the little blue guy. And you can see with the little blue guy, he started in the middle, and then he separated into two people, and then he came back together. And I said, someone kind of tell me about this graph. Is it a function or not a function? And she said, thought about it a long time. And she's like, I don't think that's a function. And I said, yeah. And notice we got two blue men when we did that. Like, that is a problem. That is why it's not a function, because every input had more than one output, and that guy came out of the Canon. I said, let's look at this one. And so we played it, and she was like, okay, I'm the blue guy, and there's only one blue guy. I said, is that a function? She goes, yes, that's a function, because every input only has one output. And I was like, yes, that's exactly what it is. And I said, all right, draw me, another thing that is not a function. And we did this back and forth for a while, but then she was really able to interact and see that every one input had one output. That meant I had one parachuter in blue the whole time. I didn't have two blue parachuters at any one time because you can't be in two places at one time. And she was like, oh my gosh, this makes so much sense. And she was able to interpret procedurally her definition so much better because her cognitive load about thinking through these words that didn't mean anything to her was a lot more efficient. So together, she got a better understanding of that topic. So really, when I'm looking at a skill, I'm hoping that students have both conceptual and procedural understanding. If they're missing any piece of those, I help provide intervention for whatever they're missing, and then they're really ready for that problem solving and transfer, because until you have both of the pieces, you can't think creatively and intuitively about your math because you're missing pieces that are going to help you be that creative thinker. So I hope this strategy helps you to think about when you're, formatively assessing students or assessing students, you're thinking about it through these lenses. And I hope some of these resources, the What Works Clearinghouse and the intensive intervention site, are helpful to you when you're looking for really great evidence-based practices that are able to be implemented in your setting. Maybe you have time to pull out students and you can do different types of intensive interventions, but maybe you were like me and I didn't have that extra time to pull out students, and so I needed things that I could easily do in the setting that I was in and just use my teaching creatively and do some different types of groupings to be able to meet those students and provide the intervention regularly right within my 40 to 50 minute math period. So I hope this was helpful. If it was, or if you need anything and I didn't provide it, I am more than happy to help you. My contact information is here on the screen. Feel free to reach out. Even in the fall, if you start working and you're like, oh, I went to this presentation, but I don't remember what they said, I'll be happy to send you anything. And I hope you have the most wonderful summer. Rest up, and I hope that your fall is a great start to the school year.